We're starting with the domain. Okay. So when you're looking at the domain mostly it talks about the x values. So what x values can this function accommodate so that it keeps on giving us numbers? So I'm trying to make it in a simpler way. I talk about it in a simpler way that you guys are going to understand. So we want to talk about a function that depends on this x. Now, for what kind of x will this function be satisfied? Will this function be defined? Okay. So now what we do is, if you are given if you are trying to find the domain for one, f of x is equal to x over 2 minus x. Here is a function that is a fraction. Okay. For what values of x will this f continue giving us numbers? So when I take x, I should get a number that I know, that I can mention. Okay. For example, if we take 1, we'll get 1 over 2 minus 1, which is 1 over 1, which is 1. 1 is a number. You get. So we've gotten a 1, which is fine. Now we want to continue getting those numbers. Let's try 2. We try 2 to be 1 over 2 minus 2, and this is 1 over 0. Is 1 over 0 a number? It's undefined. We don't know what it is. The guy is just undefined. Okay? That's where the problem is now. So when it's undefined, we're not comfortable. We want it to be defined. So what we do now is, we won't be managing to be trying numbers until we find one that is not defined. Okay? So we just get the concept that, okay, so every question that we come across, our eyes are on what could make this guy to be undefined. So if it's a fraction, we must be careful that the denominator should not be 0. So in this case, I'll go to the denominator and equate it to 0, as if I want it to be equal to 0, and see what values of x will give me a 0. So say, okay, this is minus x is equal to minus 2, divide by minus 1. So we'll get x is equal to positive 2. Meaning the domain is x, such that x is a real number, but x is not equal to 2. Like that. So this means that you can use any other value of x that is a real number, and you will get a number. The one that you cannot use is a 2, because a 2 will give us 1 over 0, which is undefined, which is not a number. So whenever it's a fraction, be careful with the denominator. Now we could have different types of functions. Let's try this one. The square root of 1 plus x. Okay. Now in the square root again, there's another thing that is very, very, very important. In the square root, we don't allow the inside to give us a negative value. We don't allow the inside to give us a negative value. So say 1 plus x should be greater or equal to 0. If it's 0, we're okay. greater, even better. So it will be x greater or equal to -1. And so we are saying then the domain is going to be x, a real number, such that x is greater or equal to -1. So if it's a root, we are talking about it not being negative. So slowly we are adding, okay? So you see, there is x on top, and there is the root of 1 plus x in the denominator. So what do we do now? The same way we didn't talk about this x on top here is the same way we won't talk about this x on top here. Okay? So we only talk about the denominator. But remember, the first thing is that it must not be 0. The second thing is that it's sitting in the square root, so it must be greater than 0. So we're going to say 1 plus x greater than 0. So meaning that x is greater than -1. So we have removed the greater or equal. We have removed the greater or equal for simple reasons that we must what? We must not allow a 0. We must not allow a negative. So our domain can also be written in this form, -1 to infinity, like that. The fourth one, f of x is equal to the square root of -x plus 2 over x over x plus 3. So here the first thing is that x plus 3 equated to 0. So we know that, oh, it's -3. So x is not allowed to be -3. What else? -x plus 2 should be greater or equal to 0. So meaning -x should be greater or equal to -2 divided by -1. So we get x is less or equal to +2. Now these two should be combined. Okay, so we are saying the domain is equal to x should be a real number such that x must be less or equal to 2, but it should not be equal to -3. So we get everything that we are restricting, we must mention it. All the restrictions mentioned. Okay. Are we comfortable there? So whenever you are asked to deal with the domain, that should be your focus. You are checking the type of function that's there, and then quickly you respond. Okay. So another one is going to be f of x is equal to the square root of 1 minus x squared. The square root of 1 minus x squared. the square root of 1 minus x squared. So here, again, we know that 1 minus x squared should be greater or equal to 0 because it's in the root. Now for this one, when you reach here, you take your time. You can ignore the greater or equal to first and deal with the 1 minus x squared equal to 0. Okay? Find the values of x squared. So it's going to be equal to 1 the other side. And then square root. So you get x is equal to plus or minus 1. Those numbers we've gotten in inequalities, they are called critical values. So critical values, when we're testing, so just get a number line and put -1 here, put +1 here, and look for any number that is not -1 and that is not +1. So I can pick a number like 0, if I so wish, and substitute it in here, in this guy. So I'll have 1 minus 0, and I'll get 1. You get? So when you get 1, we check its sign. Is it positive or it's negative? It's a positive one that we have gotten. So it means that in that region, in the interval where I got 0, I go and put a positive on top, meaning any number I could have gotten here was going to give me a positive. And so in inequalities, if I get a positive, it means that the answer need to be minus, And the question says we're interested in the interval that gives us 1 minus x squared greater or equal to 0, meaning positive or at least 0. So our domain is going to be running from -1 all the way up to +1. Like that. So your immediate exercise will be to check what the domain of this is, what the domain of this guy is. So you should try to check here and see what you're going to get. Okay? Yeah, that should be fine. Okay, so I think for the domain part, this should be fine for now. We can move a bit and look at the range. So the range, the eyes are on the y values. When we use what values of x, we don't care now. After knowing that these values of x can be used, then what y values are we getting? What is the function giving us? What is the outcome? Okay, so we'll go straight to the example. So find the range 1 f of x is equal to x plus 1 over 2x minus 3. So if it was the domain, we are going to equate the geometer to 0, but now it's not the domain, it's the range. So for the range of this type, we find the inverse. Okay, so we let y be equal to x plus 1 over 2x minus 3. And then cross multiply, so we get 1 2x minus 3 is equal to x plus 1. And then do the expansion. We are finding the inverse, so we need to make x the subject. So we put all the x one side, and then factorize. So we factorize. So this goes. So now we're remaining with x is equal to 1 plus 3y over 2y minus 1. So the question is asking for the range and not the inverse. So when we reach here, we can find the range. So how do we find the range? We find the domain of the inverse. So we're going to get the domain in terms of y. So we'll say, okay, 2y minus 1 equal to 0. So 2y equal to 1 divided by 2. So we have y is equal to 1 over 2. Okay. Y is equal to 1 over 2. So we'll say the range is y, a real number, such that y is not equal to 1 over 2. So you see, by now we know how to get the domain. So to find the range, you find the inverse and get the domain of the inverse in terms of y. Because the range is about the y, not x. The domain was about x, not y. You see? Next question. And the next example is f of x is equal to 2x squared minus 4x plus 5. We want to find the range of what? Of this function. Now, what function is this? What function is this? This is a quadratic function. Now, we saw yesterday that a quadratic function has a turning point. It's called either maximum or minimum. So the range of the quadratic function will either start from the minimum value and go to infinite, or it will start from infinite and go up to the maximum value. So first thing is that we identify our a. So our a is equal to 2. That is greater than 0. So we know that this function has the minimum. Okay. So the range is going to start from the minimum going to infinity. Now so let's get the minimum value. So the minimum value is given by the formula minus b squared plus 4ac over 4a. So that is minus negative 4 squared plus 4 by 2 by 5 over 4 by 2. So this will be minus 16 plus, that's 20 by 2, that's 40 over 8. So we're getting 40 minus 16. 40 minus 16 is is 24. 24 over 8 is 3. Okay? So that's the minimum value. So it means that our range is equal to 3 to positive infinity. That's all.
Sir,
yes.
How about using the formula negative b over 2a? It's just the same. Or we're supposed to use this one?
When you use negative b over 2a, the answer you get,
Yes.
you substitute in f, is it?
Mm,
Fine.
it's okay.
Yeah, it's okay. So if we used x is equal to negative b over 2a, we are going to have negative 4 over 2 by 2, giving us 1. And then we would have come back to f and substitute the 1. So we get 2 by 1 minus 4 by 1 plus 5. It is going to be the same 3. So whenever you use x is equal to negative b over 2a, the answer you get is not what you put in the range. The answer you get, you substitute in the function f, and the value you get is what you are taking in the range. So this is how we get the range. And now there's some more questions interesting. F of x is equal to the square root of x squared minus 5x plus 6. The quadratic. So the first thing we do for a quadratic is, in fact, let's be a bit more smart. We first check the nature of the roots. So we first check the discriminant. Remember, the discriminant is b squared minus 4ac. So you get 5 squared minus 4 by 1 by 6. So this will be 25 minus 24, which is equal to 1. So the discriminant is positive, meaning that we're getting real values of x. So meaning that this guy has got intercepts. It has x intercepts. So we can go ahead and say we want only the positive part of it. Okay. So we do this greater or equal to 0. So we're going to have x squared minus 5x plus 6 greater or equal to 0. So now you can complete the square and do the factorization. Or I can use the formula. X is equal to minus b plus or minus the square root of b squared. So I'll do it, but we have already found this. We have already found this here. Over 2a, which is just 2. So this is giving us 5 plus or minus 1 over 2. That means we'll have 5 plus 1 over 2, or 5 minus 1 over 2. So we get 6 over 2, which is 3, or 4 over 2, which is 2. So the critical values are 3 and 2. So again, we go and substitute. So there's a 2 here, there's a 3 here. and then choose any interval. So let's come to this interval here and pick a 0. The interval with a 0 is nice because it's easy to use. Then you substitute 0 wherever there is x. We'll get 6. 6 is positive, meaning this will be minus, this will be positive. We want the whole thing to be greater or equal to 0. So that the range, what are we getting? Ooh.
That question, so we were finding the domain. So
Yeah, like the solving, I'm finding the domain. I was supposed to find the range. I don't know what that mean. Okay, let me first suppose that we needed the domain as well, since I've already found it. So the domain here would be minus infinite up to positive 2 union 3 up to infinite, like that. Yeah. So this could be the domain. But then if we are finding the range, we will say after you have used these values of x, okay? After you've used these values of x, then the range is going to be only the, since we are getting the square root of the quadratic. So you'd say the range should be 0 to positive infinity. 0 is allowed. Okay, because it's a square root, positive outside. So whatever values of x you use, now we know we can use these values of x. But after we use this, the numbers we'll be getting will only be 0 up to positive. Yeah, so if it was just a range, it was enough to mention that 0 to infinity. So for some reasons, I don't know why I had to start doing for the domain. Okay, but at least it has helped the purpose because we're able to find the domain in that region as well. Okay.
sir,
Mm-hmm.
is it that we are supposed to test for the discriminant when we have such a question? Because me, I just went direct and equated it to greater or equal to 0, but I found the same answers.
When you said greater or equal to 0, yeah, you go direct. You go direct. It's on that.
No need of checking for the discriminant.
Not necessarily, but there are times when you get negative inside the root there, and then you would think that there's no domain, but the domain will be there.
Oh.
Mm. So that's the situation. Okay, so it's not that much complicated. So the domain of the root, the whole idea is it's of the root. So if it's of the root, it must be greater or equal to 0 inside. The range, you just check the sign of the root outside. And then you're able to conclude. Unless otherwise, for some special functions where the domain is so small. Okay, so those are cases when you'd be a bit careful. Now the issue of domain and range it's really important because every quiz, every test will have the domain and range. So make sure that you go through this work, and then check the total sheet, and then answer everything there on the domain and range. So tomorrow being Friday, and the quiz is on Sunday, so it will give us time to cover up the remaining pieces. Since the remaining pieces are small, they are not complicated like the domain and the range. So we can talk about all of them in one class. So let's prepare for other classes and enjoy the day. Esta Irunga request.